Floating within this hydrogen mist is helium, the second most common element. It too is a relic of the Big Bang, a silent partner to hydrogen in the great work of creation. Together, they form more than 98% of the visible matter in the universe. They are the foundation, but the most fascinating ingredient, the one that adds texture and complexity, is what astronomers simply call dust. Do not picture the dust bunnies under your bed. This cosmic dust is something far more profound. It consists of microscopic particles, smaller than the width of a human hair, made of silicon, carbon, iron, and other heavier elements. Think of it as the finest soot or a microscopic smoke. And where did this dust come from? It is the recycled remains of previous generations of stars. It is the stardust of which we spoke. Each tiny grain is a time capsule, a fragment of a long-dead sun. This dust is crucial. It acts as a shield, creating dark, cold pockets within the nebula where the hydrogen gas can cool and clump together. It is also a catalyst. The surfaces of these tiny dust grains are like microscopic meeting places, where hydrogen atoms can find each other and pair up to form hydrogen molecules. This molecular hydrogen is the key ingredient for making new stars. So, as we drift through these clouds, see them not as a random collection of gas, but as a carefully balanced ecosystem, an invisible ocean of hydrogen, seasoned with helium, and seeded with the precious, life-giving dust of ancient stars. It is from these simple, humble ingredients that all the complexity and beauty of the cosmos is born. Section 3. Emission Nebulae, the celestial canvases. Now, let us journey into a place of astonishing color. Imagine we are approaching a vast cloud, and as we get closer, it begins to glow from within. First, a faint blush of rose, which deepens into a rich, vibrant crimson, threaded with veins of turquoise and gold. We have arrived at an emission nebula. These are the most famous and photogenic of all nebulae. They are the grand art galleries of the galaxy, but their light is not their own. They do not burn like a fire. They glow like a neon sign. Buried deep within the heart of an emission nebula, or located nearby, are one or more massive, young, intensely hot stars. These newborn stars are blisteringly energetic, pouring out immense amounts of ultraviolet radiation into the surrounding cloud of hydrogen gas they were just born from. This powerful radiation acts like a cosmic charge of electricity. It floods into the hydrogen atoms, energizing them, stripping away their single electrons in a process called ionization. But the atom does not like to remain in this excited, unbalanced state. Almost immediately, it recaptures an electron. As the electron falls back into its place, it releases that extra energy it absorbed not as heat but as light. And it releases this light at very specific signature colors or wavelengths. For hydrogen, the most common transition produces a very particular shade of deep red light, known as hydrogen alpha. This is why so many of the most beautiful nebulae, like the great Orion Nebula, are dominated by breathtaking shades of red and pink. It is the color of hydrogen gas singing under the intense gaze of a young star. Other elements in the cloud sing in their own colors. Oxygen, when energized, glows in beautiful shades of green and blue. Sulfur emits a deeper red. By looking at the colors of an emission nebula, astronomers can read it like a chemical signature, understanding its composition from millions of light-years away. So when you see these magnificent portraits of the cosmos, remember what you are witnessing. You are not just seeing a pretty cloud. You are seeing a stellar nursery, alive and active, where newborn stars are illuminating their own cradle, causing the very gas they were made from to glow in a silent, colorful symphony. Section 4. Reflection Nebulae, Echoes of Starlight. From the warm, self-luminous glow of an emission nebula, our journey now takes us to a place of quieter, more subtle beauty. We drift towards a cloud that seems to shine with a soft, ethereal, almost ghostly light. It is a celestial haze, predominantly colored in tranquil shades of blue and silver. We have entered a reflection nebula. Unlike an emission nebula, the stars near a reflection nebula are not hot enough to ionize the gas and make it glow on its own. The gas of the cloud remains cool, dark, and passive. Instead, This type of nebula acts like a cosmic mirror, or perhaps more accurately, like fog illuminated by a distant street lamp. The light we see is simply the light from a nearby star, reflecting off the trillions of tiny dust grains suspended within the cloud. The process is one of scattering. The starlight enters the cloud, and as it encounters the microscopic particles of dust, it bounces off in all directions. But not all colors of light scatter equally. Blue light, with its shorter wavelength, is much more easily scattered by these tiny dust particles than red light, which has a longer wavelength. The red light tends to pass straight through the cloud, or is absorbed, while the blue light is deflected and scattered, filling the nebula with its characteristic cobalt hue. This is the very same reason that our own sky on Earth is blue. The sunlight entering our atmosphere is scattered by the tiny molecules of nitrogen and oxygen, with the blue light scattering far more effectively than the red, filling our daytime sky with its familiar color. A reflection nebula is, in essence, a celestial echo of our own blue sky. The Pleiades star cluster, the famous Seven Sisters, is a perfect example. The brilliant young stars of the cluster are currently passing through a vast, unrelated cloud of interstellar dust. The light from these stars illuminates the dust, creating the delicate, wispy blue nebulosity that clings to them like a veil of silk. It gives the impression that the stars are shrouded in their own cloudy cradle, but it is merely a beautiful chance encounter in the vastness of space. As you gaze upon a reflection nebula, contemplate its passive, gentle nature. It is not a place of creation, but a place of quiet illumination, a silent testament to the dust between the stars, made visible only by the light of a passing traveler. Section 5. Dark Nebulae, the cosmic silhouettes. Our journey now takes a turn, away from light and into the shadows. We move towards a region of the sky that appears, at first glance, to be empty. It is a hole in the heavens, a patch of profound blackness where there should be stars. It looks like a void, a rip in the fabric of the galaxy. But this is an illusion. We are not looking at emptiness. We are looking at a dark nebula. These nebulae do not emit light. They do not reflect light. They obscure it. They are the truest clouds in the cosmic sense. A dark nebula is an interstellar cloud of dust and cold gas that is so dense, it completely blocks the light from any stars or glowing nebulae that lie behind it. It acts as a celestial curtain, creating a stark silhouette against the rich, starry backdrop of the Milky Way. The famous Horsehead Nebula is a classic example. What we see as a familiar shape is not a structure in itself, but a dense, dark finger of dust and gas protruding in front of a brilliant pink emission nebula, IC 434. The horse's head is visible only because the bright nebula behind it acts as a cosmic backlight. Without that backdrop, the horsehead would be completely invisible to us, lost in the blackness of space. These dark clouds are not just beautiful and mysterious shapes. They are of immense importance. Their darkness is a sign of their density, and their density means they are cold. The thick dust shields the interior of the cloud from the heating radiation of nearby stars, allowing temperatures to drop to just a few degrees above absolute zero. In this profound cold, the gentle, persistent pull of gravity can begin its work. The cold gas and dust can begin to clump together, to coalesce, to slowly, inexorably collapse under their own weight. So, when you look upon these regions of shadow, do not see an absence. See a presence. See a concentration. These dark, silent, cold clouds are the very seeds of future stars. They are the quietest places in the galaxy, but they are pregnant with potential. They are the calm before the storm of creation, the place where the next generation of suns is quietly gathering its strength, hidden from our view, waiting for the moment to ignite. They are the future, written as a shadow on the present. Section 6. The Wombs of Creation Stellar Nurseries. Let us now pass through the veil of a dark nebula and venture into its heart. Here, within the coldest, densest regions, we find the true purpose of these great clouds. We are entering a stellar nursery, the womb of the cosmos. The process that unfolds here is not violent or sudden. It is a slow, patient, and magnificent dance orchestrated by gravity. For millions of years, the cloud drifts in a delicate balance. The gentle outward pressure of the gas is matched by the gentle inward pull of gravity. But this balance is fragile. A disturbance, perhaps the shock wave from a distant supernova, or the gravitational nudge of a passing star, can push a region of the cloud past its tipping point. Imagine a small, slightly denser clump within the vast cloud. Its gravity, though minuscule, is now slightly stronger than the gravity of the space around it. It begins to pull in more gas and dust from its immediate vicinity. As it gathers more mass, its gravitational pull increases, allowing it to pull in even more material and faster. A slow, inexorable feedback loop has begun. A cosmic snowball effect. Over hundreds of thousands of years, this collapsing core grows denser and denser. The pressure at its center builds, and with that pressure comes heat. The frigid cold of the dark cloud begins to give way to a faint, nascent warmth. The clump is no longer just a clump. It has become a protostar, a star in embryo. It does not yet shine with the fire of nuclear fusion, but it glows with the heat of its own compression, a dull, deep red ember hidden within its dusty cocoon. This protostar continues to feed, siphoning material from the surrounding cloud through a swirling disk of gas and dust known as an accretion disk. It is within these very disks that planets will later form, from the leftover dust and debris. Finally, after a long gestation, the core of the protostar becomes so hot and so dense, millions of degrees, that a miracle occurs. The crushing pressure forces hydrogen atoms to slam together and fuse, forming helium. In that moment, a colossal amount of energy is released. The protostar ignites. A star is born. The newborn star awakens with a furious burst of light and stellar wind, which blasts away the remaining gas and dust of its cocoon, revealing itself to the universe for the first time. It emerges from its nursery, often in the company of hundreds or thousands of sibling stars that all formed from the same great cloud. A new star cluster, blazing in the darkness. This is the ultimate secret of the nebulae. They are the fertile grounds from which the lights of the universe are born. Section 7. The Final Breath, Planetary Nebulae. We have witnessed the birth of stars, but the cosmic cycle is one of both life and death. And in death, there can be a strange and breathtaking beauty. Let us now journey to the end of a star's life. Not a massive star, but a star like our own Sunday. When such a star exhausts the hydrogen fuel in its core, it does not explode. It dies a much more graceful, elegant death, creating one of the most exquisitely structured objects in the cosmos, a planetary nebula. The name is a historical mistake. When they were first discovered in the 18th century, their small, round, greenish appearance through early telescopes reminded astronomers of planets like Uranus. We now know they have nothing to do with planets. They are, in fact, the star's final beautiful act. After billions of years of stable burning, a sun-like star begins to swell, becoming a red giant. Its outer layers expand and cool, puffing out into space. In its final phases, the star becomes unstable. It pulsates, and with each pulse, it gently shoves its outer atmosphere of gas out into the surrounding space. It is not an explosion, but a series of powerful, super winds that carry the star's outer layers away, forming an expanding shell of gas. What is left at the center is the star's tiny, incredibly hot, and dense core, a white dwarf. This dying ember is no longer producing new energy through fusion, but it is still blisteringly hot from its former life. Its intense ultraviolet radiation streams outwards and illuminates the shell of gas that it just ejected, the gas that used to be the star itself. Just as we saw with emission nebulae, this radiation ionizes the expanding gas, causing it to glow in a spectacular array of colors. The intricate shapes we see, perfect rings, butterfly wings, hourglasses, or spiraling eyes, are sculpted by the star's rotation, its magnetic fields, and the way the gas was ejected. We are seeing the complex history of the star's final years, written in glowing gas. A planetary nebula is a fleeting ghost. It expands and fades over just a few tens of thousands of years, a mere blink of an eye in cosmic time. Eventually, the gas will dissipate into the interstellar medium, enriching it with the carbon, nitrogen, and oxygen that was cooked inside the star over its lifetime. And the central white dwarf will slowly cool over trillions of years, eventually becoming a cold, dark cinder. When you see a planetary nebula, you are witnessing a star's beautiful, serene, final breath, a gift of new elements returned to the cosmos. Section 8. The aftermath of giants' supernova remnants. The death of a sun-like star is a graceful sigh. The death of a star more than 8 times the mass of our sun is a roar that echoes across the galaxy. These massive stars live fast and die young, ending their lives in one of the most energetic events in the universe, a supernova explosion. And what is left behind is a different kind of nebula, a testament to immense power, a supernova remnant. In the final moments of its life, a massive star's core collapses under its own tremendous gravity. This collapse triggers a catastrophic rebound explosion. In a fraction of a second, the star unleashes more energy than our sun will in its entire 10 billion-year lifetime. It shines brighter than its entire host galaxy. The outer layers of the star are blasted outwards into space at incredible speeds, thousands of miles per second. This expanding wave of stellar material, known as the ejecta, slams into the surrounding interstellar gas and dust with unimaginable force. It creates a powerful shockwave, a cosmic tsunami that heats the gas to millions of degrees, causing it to glow brightly, not just in visible light, but in X-rays and radio waves. What we see as a supernova remnant, like the famous Crab Nebula, is this tangled, filamentary web of ejected material and shocked interstellar gas. The Crab Nebula is the wreckage of a star that was seen to explode by Chinese astronomers in the year 1054. Today, nearly 1,000 years later, the cloud is still expanding outwards at over 3 million miles per hour. Its intricate, web-like structure is the result of the violent explosion, shaped by the star's magnetic fields and the turbulent mixing of its own guts with the space around it. But this violence is profoundly creative. It is in the crucible of these supernova explosions that the heaviest elements in the universe are forged, elements like gold, silver, lead, and uranium. The star, in its death throes, creates these precious materials and then blasts them out into the galaxy. The shock waves from the supernova can also compress nearby interstellar clouds, triggering the collapse that leads to the formation of a new generation of stars. A supernova remnant is a chaotic, beautiful scar on the heavens. It is a memorial to a giant and a forge for the elements that make rocky planets and complex life possible. It is the most violent form of recycling, ensuring that the death of one great star provides the seeds for countless new worlds. Section 9. A deeper connection. We are stardust. We have journeyed far. We have drifted through clouds of glowing hydrogen, past silent silhouettes and echoes of starlight. We have witnessed the birth of suns in stellar nurseries and watched them die, either in a graceful sigh or a galactic roar. Now let us pause and bring this cosmic story home. Let us connect the threads, from the farthest nebula to the very heart of our own being. Consider the cycle. A vast, cold, dark nebula, seeded with primordial hydrogen and the dust of ancient stars, collapses to form a new star and its planetary system. That star lives its life, burning hydrogen into helium, and then into heavier elements like carbon and oxygen. If it is a star like our sun, it ends its life as a planetary nebula, gently releasing those elements back into space. If it is a massive star, it explodes as a supernova, forging the heaviest elements and blasting them across the galaxy. This newly enriched gas and dust, the remains from planetary nebulae and supernova remnants, mixes with the interstellar medium. It becomes part of the next generation of nebulae. The cycle begins again. Each generation of stars is slightly more enriched with heavy elements than the last. The universe is slowly, patiently, building complexity. 4.5 billion years ago, one such enriched nebula collapsed. At its center, our sun ignited, and in the swirling disk of leftover dust and gas, our planet, Earth, formed. The dust grains, containing carbon, oxygen, silicon, and iron, all forged in the hearts of long-dead stars and scattered by nebulae, clumped together. The iron that was forged in the heart of a supernova now flows in your blood, capturing oxygen with every breath you take. The calcium from a dying sun-like star now forms the structure of your bones. The carbon, the fundamental building block of all life on Earth, was created inside a red giant star and cast out into space. The nitrogen in your DNA, the potassium in your nerves, every single heavy element that makes up your body, your world, the food you eat, the air you breathe was created in a star and delivered by a nebula. This is not a metaphor. It is not poetry. It is the literal scientific truth. You are a walking, thinking, feeling collection of stardust. You are a way for the universe to know itself. When you look up at the night sky and see the faint smudge of the Orion Nebula, you are looking at a place where new stars and planets are forming right now. But you are also looking at a reflection of your own deepest origins. You are looking at the same kind of cosmic womb from which our solar system, and ultimately you, emerged. The universe is not something out there, separate from us. We are an intricate, inseparable part of its grand, cyclical, and ongoing story. Section 10. Conclusion: The Whispering Cosmos. Our journey is drawing to a close. We have drifted on cosmic tides, from the genesis of stars to their beautiful and profound endings. We have learned that nebulae are not static objects, but dynamic, living processes. They are the great looms of the cosmos, weaving the fabric of existence from threads of gas and dust. They are the bridge between stellar death and new life, the alchemists that turn the ashes of the old into the building blocks of the new. In the glowing crimson of an emission nebula, we saw the passionate song of newborn stars. In the cool blue of a reflection nebula, we heard the quiet echo of starlight. In the stark black of a dark nebula, we felt the profound potential of a future waiting to be born. In the final, graceful bloom of a planetary nebula and the chaotic splendor of a supernova remnant, we understood that even in death, the universe gives back, enriching itself for the next cycle. And most importantly, we have discovered that this grand, celestial story is not separate from our own. The secrets of the nebulae are our secrets. Their history is our inheritance. The next time you feel small beneath the vastness of the night sky, remember this connection. Remember the iron in your blood and the calcium in your bones. You carry the legacy of exploded stars within you. You are a child of the cosmos, assembled from the dust of these very clouds. Let this understanding be a source of peace and wonder. The universe is not a cold, empty void punctuated by random events. It is a connected, coherent, and deeply beautiful system of creation, recycling, and rebirth. And we are privileged, for a brief moment, to be a conscious part of it. Thank you for joining this peaceful exploration. May you continue to look up and to see not just points of light, but the grand, whispering story that connects us all. Carry this sense of wonder with you, and let it be a gentle light in your own world.